Okay, so what we're getting into now is graphing of trigonometric functions. Okay, so um, there's going to be a lot of similarities. Like every one of our units so far, we keep on doing like graphing of each one, and then we got those transformations. And again, it's going to be very similar. We're going to have lots of the same types of transformations. But in this lesson, in this first one here, I'm just going to talk about generally how we get to some of these strange looking graphs that we're going to do here in a minute. So lesson 34. So really like looking at the basics or basis of like how do we get a sine function and how do we get a cosine function. And you know what, I think for time's sake too, like what I've done in the past is I actually graphed on here like point by point to come up with a sine function. But I think what I'm going to do instead is I'm going to just bring up this little gizmo thing because I think it shows it really well. So on here, right, you can move this thing around to our special coordinates, right? So for example, like at this point right here, right, that would be our that would happen when you've got like this point. Maybe I'll turn on my drawing function here. Okay, so this point right here, right, this would be at √3/2 comma a half. And remember what that means, okay? So what this means is that you'd have an x value of √3/2. So that's this, right? That's our x value of √3/2. And then a y value of a half. So that's that, okay? So now if we want to turn this thing into an actual graph of this function, you can see we have that down below here. Oh, right, okay. Okay, so what's going to happen here is that as we move this guy around, erase a little bit of stuff there. But as we move this guy around, right, you can see that what we have along the x-axis in this case is you've got pi, you've got 2 pi, you've got 3 pi, you've got 4 pi. All right, so what is that talking about? Well, what we're graphing across the x-axis is when we move this arm all the way around the circle. So when it shows this point here of pi, right, on our axis there, well, that would be here, right? You guys remember that pi would be all the way around to that point, right? So this would be pi over 2 would be up at the top, and this would be 2 pi, or sorry, 3 pi over 4. 3 pi over 4 on the bottom there, right? So, oh, sorry, 3 pi over 2, my bad. 3 pi over 2 on the bottom there. Okay, so as we work our way around here, you can see that right here, right? So if we have a cos graph, then we're starting at 0, right? So like we've started at the point 0. Now cos, you can see on our line here, as I move this around, remember from before that cos really is like the x value. So cos is like the length of that line right here at any given point on the circle, right? So then when I say a cos graph, that's what I'm talking about, like the x value all the way around. And then so as I go around here, notice that at the beginning, it's at 1, right? You've got it at 1. That's what this corresponds to right here, right? It's at 1. It has a length of 1 at that point. Okay? And then as I move it up, it gets shorter, right? It gets shorter. That one's shorter now. And then as well, and we know what it is, right? It's at √3/2. That's the length right there. As I move it up, then this length of this line right here in our graph, that would be, well, right there, that's at √2/2. Right? I didn't draw that there, but that's at √2/2. And you can see that here, right? √2/2. As I move it up again, now I would be at a half, right? That's what that would be. This would be right at a half, right? So if that was 1, I'm at a half now. And then look what happens here. Right when I bring it up to pi over 2, I have no more x value, right? I've got no more cos value. So that makes sense. I'm right on the line, right? It's 0 at pi over 2. So the cos graph is 0 at pi over 2. If I keep going around the circle, then we can see now the x value has jumped to the left side of the graph. So now I'm talking about negative x values. That's why I'm below the line here, right? Negative x values. That's why I'm down here now. And this would be at negative a half, right? That's what the x value would be at that point. And then I'd be at negative root 2 over 2. And then I would be at negative root 3 over 2, right? That's the length of your x there. And then when I go pi all the way around again, now I'm at negative 1, which makes sense. I'm below the graph, right? I have a negative length, or a length of negative 1 at that point. And I think it's worth keeping on going around, because you can see now my x value, right? My x value here is at negative root 3 over 2 again, negative root 2 over 2, negative a half. And then again, here's another key point where now I have 0 x value, right? The line's straight up and down at that point. That's why I have 0, right? That's where it crosses the x-axis here. So 0 again. And then now I'm back into the positives, right? Now I'm back into the positives. I'm above the line at this point. And then around, and then I'm back to where I started. But this pattern, right, would keep on going. So if I had something that was moving around and around in the circle, then the line just keeps happening. You can see that it would just form this pattern. There are a ton of things in nature that do this, right? That have a circular pattern to them. And then scientists can use these graphs quite often. It actually comes up way more than you would think, especially in physics, these sine waves and these cosine waves. So yeah, so that's the general idea. So we're looking at that's a cos graph right now, right? So let's change it to a sine graph. You guys see what changed there? So cos graph, I started at 1, right? That was up at the top. So that was 1 at that point. Now the sine graph starts right at the origin. Well, this actually makes sense if you think about it, right? Because remember what sine is, right? Sine really is like our y value. So if I'm looking at like just this point again, this point was root 3 over 2 comma a half, right? So that's my y value. That's my sine value is my y value at that point, right? So we can do the same thing. We can keep going around and around the circle. And I think it'd be worth doing it to say, okay, so we're at a half, and then we're at root 2 over 2, right? That's what this point is if you look at your unit circle for the y value. And then we're at root 3 over 2 at the top. And then right when we get to pi over 2 again, right up at the top here, now we have a y value of 1, or a sine value of 1. Okay, so that's our peak. That's our max right there. And then going around, I'm still positive, right? I'm still positive. I'm still up here. I'm still positive, still positive. And then I get down again to pi, right? Right at pi, I have a value of 0. You guys kind of see how these things are just they're pi over 2 difference, right? A cos graph and a sine graph are really the same thing. They just start at different points and they cross the x-axis at different points there. But that's really it. And then again, you can see now I'm into my, am I doing sine I want? Yeah. So now I'm into my negatives here, right? Which makes sense. I'm into my negatives, and then I'm at negative 1, and then around and around, right? So hopefully that makes sense. You can do the same thing with degrees if you like, but that just changes my x-axis here to degrees instead, but it all still makes sense, right? At 90 degrees, I'm at 1. At 180 degrees, I'm at 0. Okay? So, all right, so we'll go back to our notes now. So that's really everything that would be happening here, right? So if you were graphing this, you could start for a sine graph at 0. That's a good one to remember, is that sine starts at 0 and cosine starts at 1. Okay, so if you're doing these, and then you would end up with a graph going up and down like that, right? If you actually graphed each of these points, so graph it at 30, 45, yada yada yada. But that's really just everything I did on that little gizmo there. So okay, so now it says determine the following from the graph. So let's determine the following of these graphs, or of these things from our little gizmo there. So I'll turn it back to a sine, yeah, so sine graph. And it says, the first one here says, determine the x-intercepts. Okay, so the x-intercepts, they're going to be happening at, well, 180, 360, 540, yada, 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 right? Just it's going up by 180 every time, right? So what we can say here is it's going to happen at 180 n, and then just bear with me, 180 times n, where n is a member of the integers. So that might sound kind of confusing, but all that's saying there is that you've got 180, and then n could be, well, that could be 1, that could be -1, that could be -2, right? So the negatives here, if I had like -1, well, that would mean that I was just going this way, right? Because like 1 times -1 would be -80. So there is an x-intercept. 180 times -2 would get me to -360, right? So, and then also at 0. So if I put 0 in for n, then that would be 0. Hopefully that kind of makes sense there. Another way of writing that one, if we were dealing in radians, it'd be very similar, but you'd say, well, it's going to happen at intervals of pi, right? So you'd say pi times n, or n pi, either way, where n is a member of the integers. Okay, so you're going to start seeing this notation quite a bit. I guess we have in the last one anyway, so yeah. Okay, y-intercepts, so where does that happen? So your y-intercept for a sine graph is going to happen at the point 0, 0. Okay, now amplitude. So if you guys have been in physics, then this should come in handy because we've used some of these terms before. Amplitude is how high are we from the from our midline, from the middle there, right? So our amplitude in this case is going to be 1. Okay, and I know it could be -1 as well, but it's actually like the absolute value of it, or it's like the magnitude, you'd say in physics, right? So your amplitude in this case would be 1. Okay, the period. Okay, so remember what period is. So we look back at our graph there. The period is how far do we go along the x-axis before the pattern repeats. So now what this could be is, it like, let's say we started right there, right? How long until the wave looks the same again? How long until the pattern repeats? So if I was looking at from this point, I can see that this thing is on its way up at this point right here, right? And then if I go all the way over to 360, it's on its way up again. So the pattern's starting to repeat again right there. So this is my period. So the period would be like from there to there. So the period would be 360 degrees. Or if you were dealing in radians, then it would be 2 pi, right? So whatever one you were looking at there. Now, you could start from that point like I just did there, but I just want you to see that you could start really anywhere, because if I started from like a peak to another peak, right, that's where this is on its way back down again, this is on its way back down again, the pattern's starting to repeat there again. So if you went 3 pi over 2 minus pi over 2, well, again, you're going to end up getting pi over, or 2 pi for your period there, right? So either way, it's just from where the pattern starts repeating itself again. That's your period. Okay, so period, so we'll say 180 degrees. 360 degrees. What am I talking about? 360 degrees. All right, median. So the median for this graph, or sine graph, would be the middle, right? The median is actually, you can think about it as a line that splits this thing right down the middle. So it'd be like this line going right there. And this one seems kind of obvious because it's right at 0, right? This is when y is equal to 0. That's our median. But we're going to do what we've been doing in other lessons, where this graph will be shifted up, it might be shifted to the left, everything else, right? So the median is going to be right at 0 for us for now, though. but that'll change. Okay, so the median would be happening at like the line y is equal to 0 in this case. Maximum, all right, so the maximum is going to be at y is equal to 1, right? That's as high as that thing ever gets. It only ever goes up to 1 and then goes back down again because we're on a unit circle, right? The arm of this thing is only at 1. It can only ever get to 1 at the top, right? So then the minimum, y is equal to -1. All right, so the domain of these guys, these graphs actually extend forever, right? You can see the arrows in the end of these things. They can go on and on and on forever. So we just say x is a member of the real numbers. And then your range, well, y has to be greater than or equal to -1 or less than or equal to 1. Or, you know, written in interval notation would be -1, 1, right? With the square brackets because it's also including both those numbers. Okay. So the thing to notice here, the amplitude is the vertical distance from the median, halfway between yada yada. Yeah, that I kind of explained everything there. So okay, so now the next one's cosine function. I'm not going to do all the same. There's a lot of similarities, but I think for the sake of time, I'm gonna skip past that. But this part does say, so what's the difference really between a sine graph and a cosine graph? You can think about this as a phase shift, but looking back at this, like I was saying before, if you go back and forth from a sine to a cosine graph, you can see that it's really the same, but the whole thing has been shifted in the x direction, right? That's going to be like our c values that we've been shifting in every other one, right? So if we took the whole graph and just shifted it to the left or the right, we're going to end up getting the other, if you had a sine graph and shifted it to the right, you can get a cosine graph, or the left, doesn't matter. But the shift is actually going to be a shift of pi over 2, right? It's going to be like a 90-degree shift either way. All right, so that's the idea. Now, a couple things that you guys are going to have to, well, memorize or just know how to get to that point is how to figure out the amplitude and how to figure out your median, right? So in this case here, I'm going to make a little graph. Okay, so if we have this graph and we are going, let's say we had it like up here. That was terrible, but anyway. Now, our median would be the number that this graph is like centered around, right? So the median is how high up is like the center of this graph. Okay, so that's like our middle number between like our max and our min. Okay, so if I want to find the median, sorry, I can't do this out of order, but what this would be, like the middle number between those two, this one is really just asking for what's the average between the top number and the bottom number, right? Because if let's say our top number here was 6 and our bottom number here was at 2, then you can probably look at that and be like, okay, well, that's got to be 4, right? The middle of that's got to be 4. Well, 4 is just the average between 6 and 2. And another way to find an average is just to take the two numbers, right? Take 6 plus 2 and then divided by the number of numbers that you're finding the average of. And that again would be that end up giving you 4, right? So that's how you find that one. That's also going to be, like in the next lesson there, that's also going to be our d value in our equation. We'll get to that though. That's going to be our vertical shift up or down, okay? Okay, so now the amplitude though, so remember what the amplitude is. The amplitude is how high is this thing from here to here. Okay, well, we could figure that out by going our max number, right? Max number, so 6 in this case, minus our min number, so 2, and think about what that just gave us, right? If I go 6 minus 2, then that's actually just telling you this length, like the whole length, right? Or the whole up and down, right? Like the whole y value there, the whole wave height from top to bottom. But if I want amplitude, I only actually want this top part, right? So I'm going to just divide that by 2. So these are they look very similar, but they give you different things, right? Max minus min divided by 2 gives you the amplitude. and then max plus min divided by 2 gives you your d value. Now, these aren't on your formula sheet, so you guys need to know how to find those things. Okay, the period of your graph, the period of these graphs, another one that's not on your formula sheet, will always be period is equal to 2 pi over your b value. Or you can think about the other way, your b value is going to be equal to 2 pi over your period. And that's really just because one, like according to our base function, right? We haven't done anything to a sine graph or a cosine graph, then the period will be 2 pi. So you're just actually figuring out, you know, what ratio, I guess you could say, of the original graph are you left with, right? When you divide those. So again, this one's not on your formula sheet, so you need to know how to get to that one on your own there. Okay, so examples. So this one says, state the amplitude of each trigonometric function. Okay, so the amplitude in this case, and you know what? I don't have it on here. It's definitely worth, let's write down our formula now for, oh, sorry, all over the place, for graphing a function, because I think this will help. So this actually is on your formula sheet as well. If you look, documents, formula sheet, it's actually these ones, right? You've got these two on your formula sheet already. So do you see how we got A, right, is like the number out front, and then you've got B, right, like you got to see the B and everything else like we've been doing in every other unit, and then you've got your C value and you got your D value. Those are all the same letters that I'm dealing with right now. So when it says what's the amplitude, that's nice because amplitude starts with an A, so it's an easy one to remember. That actually is going to be your A value up front. So if we go back here, your amplitude of this guy really is just going to be 1 over 4. So that's kind of an easy one to see, like just straight from it, right? Okay, now this one, y is equal to -3 cos 1/2 theta. Okay, now in this case, it's -3, but I know that amplitude is an absolute value, right? It's like the positive version of it because it's just how high or low is it from our midline. This is actually just going to be 3. So your amplitude here would be 3, you'd say. Okay, so number 2 says state the period of each trigonometric function in degrees and in radians. All right, so if our function there was, here, let's write it down. Y is equal to A cos of B, and then it's like theta minus C plus D, right? Like that's a general equation that we're going to use here. Now, this is our B value, right? That, or like that 2 right there, that is already our B value. So the B value is 2, and if it wants the period, then that was this one up here, right, that we just did. So the period here is going to be equal to 2 pi over our B value. So that's going to be 2 pi over, and then that's 2. So our period here is going to be, those cancel, and we get pi. Now I can do the same thing with 180. You go 180 divided by 2. Either way, I know pi is the same thing as 90 degrees. So that's going to be my period in degrees. Okay, now this one, so same type of thing here. We're going to have our period will be equal to 2 pi over 1.5. Okay, so that's the same thing. You can write it out again as 2 pi over 3 over 2, which would be, so dividing by a fraction is the same as multiplying by reciprocal. That would be 4 pi over 3. Okay, and then 4 pi over 3, 4 pi over 3 is 240 degrees. Now I could have found that, just so you're aware, we could have went 180 degrees, right? Or sorry, no, sorry, 360, because it's 2 pi. Yeah, so 360 degrees over 1.5, you again would get 240 degrees. All right, so that's the idea. Number 3 says find the period amplitude of, now we're just looking at the graph, right? We got to figure it out from that. Okay, so in this case, looking at this graph, it says, you know, I want to find the period and amplitude. Let's do amplitude first. So the amplitude is this. That's my amplitude from the baseline. How high up does it go? Okay. So in that case, it's going to be, well, it goes up to 0.5. And it goes down to negative 0.5 too. I should have looked at that, right? So this thing is centered around 0. So our amplitude here will just be 0.5. And remember, I also could have found that number by using this, right? I could have went 0.5 minus negative 0.5, right? Which would have been like plus, so that would have been 1 and then over 2, so 0.5. So we got the same thing. Okay. Now, let's find the period of this guy. So the period is going to be, where does this thing repeat? Okay. So I'm going to make the assumption that this thing crosses through 0. And then they've given me this point here, right? So it goes from the point 0, 0, where my x value is 0, right? X value is 0. And then to this point where it's 4.71. Okay, so it's 4.71 to this, right? But the period of this thing is actually going to be all the way to here, right? It's on its way up right there, and it's starting to be on its way up again right there, right? The pattern's repeating at this x-axis. So in this case, all I got to do is go 4.71 times 2. Okay, so the period is going to be equal to 9.42. All right. Okay, next one. So your amplitude of this guy, you can probably just see it, right? We haven't had too much going on. It's going to be 2, right? It's 2 to the top. It's 2 to the bottom. Our amplitude there is 2. But again, I could have went use my equation, right? Max minus min divided by 2. So that, yeah, either way. Now period. So the period. So if I go from this point, right, to this point, can you see that that's half of the wave, right? So from there to there, and then down here again, that would be one full wave, right? It's on its way up, and then it's on its way up again right there. The pattern's repeating. So it was 60 to this point, so it is 120, right? It's going to be 120 for the whole, for it to start repeating again. Okay. Now, one complete cycle for each guys, for the sake of time again, I think this is one that, that you guys can do right too. Well, yeah, this might be worth doing. So let's look at our original function here. So our original function would just be y is equal to sine theta. Okay. So if we were graphing this, so this line doesn't line up very well. It should be happening like right here, right? But just pretend it does. If I went over 3, I'm going to go over 3 where I make my things line up. So that'd be pi. And then over 3 more, I'm going to have 2 pi. And then 3 more, 3 pi. I'm going to zoom in. There we go. 4 pi. 5 pi. 6 pi. All right. And then just generally, gets this thing out. So it's a sine graph. So I know sine graphs start right at the origin. So pretend that is where the origin starts right there. And then it's going to cross at pi, right? So I know this thing is going to go like up from here. It's going to cross at pi. So it's going to be at 1. I'll make 1 4 blocks up. This will be at 1, and then 4 blocks down will be -1. Okay, so right in the middle, right at this point is where it would be at 1. So that's going to be at, well, pi over 2, right? So pi over 2 would be at its peak. And then it comes back down again. And then again, it would be right there. And then there. Here, I'm going to draw all my peaks. All right, so it goes up and then down. Okay, so that's just the base sine function, and it really would actually be the same coming along the other, like the back side of this too, right? And then it would be the same that way. Okay, so that's just y is equal to sine theta. So now what we're going to do is it has a horizontal stretch or a b value of 1/3. Okay, so let's actually figure out what that means as far as our period actually goes here. So period, remember, is 2 pi over b. So our period is going to be 2 pi over, and then our b value is 1/3. So that'd be the same. So dividing by a fraction, the same as multiplying by reciprocal. So that would be p is equal to 6 pi. All right, so what does that mean? That means that this thing repeats the pattern every 6 pi. So is going to cross at 6 pi. I know that that's going to be my whole wavelength. It'll be from there to there. I know that it's going to cross part way in between, and then it'll go, it's going to go up there, down there, and then back up again, right? So I can also see that halfway in between, 3 pi and 0 is going to be my max now. So that's going to happen here and here. And then that's generally it. Now we can sketch this guy. Oh my God. There is our new graph, and you can see what happened, right? It's the same type of thing before. When we stretch these guys, this is 1/3. What that really did is, you can think of any point on this graph, right? That point there, that got multiplied by 3 to give me that point there, right? It's like the opposite. It's like the inverse of what's actually happening there. Every point. So same thing. You had this point was at pi. Now it's at 3 pi, right? It's been multiplied by 3 and so on, right? So this was at 2 pi and now it's at 6 pi. Everything got multiplied by 3. It stretched that thing out. So if you get like a number like 1/3 or 1/2, like a small number, then it's actually going to stretch the thing out and make it actually wider. It's going to pull it apart. Okay. Hopefully that made sense. And we'll find other ways to get more accurate. Like I didn't talk much about how to find these. But what I think probably the best way to do these as we get going, we'll start to use that mapping notation, right? Like what does the point XY turn into? Because this gets a little bit tougher when we get stretches and reflections and everything else. So, but just in general, that's just a good start. Okay. So, you know what? We're going to do a ton more of these type of things in the next lesson. So if you can, I'll get you guys to try this one, but you'll do some examples anyway. So yeah, I think I'm just going to leave it there.